Yes. They're not. There's a few different things that are called nodes in mathematics, but you couldn't make anything. But whatever helps you look at it.
Whatever
It helps you. Yeah.
See, it can't touch there. So when you draw your graph, it's a 0, right? Your 1 is a 0 here. Is that the answer for this one?
I don't know. Which one are you? What's going on?
Number 17.
Practice test. What's the problem when you come into this?
Yeah, good. I like that. So you can call that a node. Very often in mathematics, a node is kind of like where things cluster sometimes, or things are drawn towards it. But you can call that a node. Why not?
As long as it is explained.
So a node in physics is a part of a wave that doesn't move. Right? You have a node and an antinode, the one that moves the most.
This is a.
So that's just something. All right. All right, guys. So hopefully everybody got a practice test. Okay. So that's the third time I asked. I always have to ask at least 3 times, then I catch everybody. I've got the answer key for that. We can talk about and do whatever examples, concepts.
But on the top 2.
Pretty much entirely up to you what we look at and do to get ready for the test. It's not up to you what the test is going to have on it. Don't get too excited.
Reading number
All right. Hey.
16 on the practice test, which was the volume thing out of the book. Number 20, page number 22 on page 292. Looking at the which I think inside of the book, the outside of the
So this is number 16 on the practice test. And that references page 293, number 22.
The volume of the shelter.
Which then references, no, that's enough. So this is a small shelter for delicate plants. Is to be constructed of thin plastic material. Neato. It would have square ends and rectangular top and back. So the ends are square. And the back and top. And it is open. Do this, Jeff. So that. Neato. Just as good as the book's picture. Yes. Open bottom and front. So the total area of the 4 plastic sides is to be 1,200 square inches. Cool. Express the volume as a function of the depth. Draw a graph, blah, blah, blah. So very often I'll teach this. I'm not sure why I haven't done this yet this semester, but I'll teach this as they tell you something and then they ask you something. Here they told me the area, and now I just have to figure out what the expression for that would be. And then they asked me for the volume. So they have to give me some information to get me started. So what is the equation for that area? The total surface area here.
You got some x's.
Yeah, what's the area this side here?
4x.
X squared, and you got a couple of those, right? You got
2x
X squared. Plus, what's this back rectangle and this top rectangle? I think they said this is y, right? Yeah.
X1.
Yeah, so it's going to be xy, and this will be xy. So you got 2 xy's. Cool, so that's where you start. How do I represent what they tell me with an algebraic expression? So the algebraic expression for the area would be x squared plus 2xy. Yes, ma'am? 2x squared, thank you. 1x squared, another x squared. Which is even nicer because now I can cut it all in half.
What about the back side?
That was those words.
Yeah, there's 2 rectangles,
Okay.
and then she helped me out with the fact that there's 2 squares.
Oh, I see.
Cool. So now I can kind of clean this up just a little bit. Get that. Now they asked me to write the volume, express the volume as a function of x.
So you have to solve for it.
So what's the volume just by itself? Volume in terms of x and y. And you can actually write that as like that. Volume is a function of x and y. What would that volume be? Yeah, x, y. Cool. Right? Does the volume care that there are sides missing?
No.
No, the volume doesn't care that there's sides missing, right? So x, y, better known as x squared y. Cool. So to write that as purely a function of x, which variable do I have to replace? Y. I've got to replace y with some function of x itself so that I end up with volume only having x in it. So I want to replace y with some expression with just x in it. So how do I do that?
Use that.
Thank God I have a relationship, they told me, between y and x. I can solve this for y and then plug it in there.
How come it's so easy when you do it?
It's that difference between watching and doing.
So
Huge difference, yes.
the process is you find the two equations and then you find the relationship
Yeah.
and then substitute.
I desperately want you guys to get this. They will always tell you something. They have to give you some information and get started. And that really, what that information is given to you for is to connect the variables involved. There must be some relationship between them so I can end up with an expression that only has one variable in it. We are not in multivariable analysis yet. That's a few semesters down the road. We can deal with it when it has a single variable. I can find the maxes and mins. I can graph that thing. I don't have a calculator that can graph in 3 or 4 or 80 dimensions. I wish I did. That'd be cool. Calculator unfolds itself. So what's the next step then? Remind me. Don't want to do either x or y. I must solve this for y.
Yeah, for y. So
Thank God, because solving this for x would suck. I don't know if you guys see that. There's no way to get x by itself directly. You have to actually do some kind of weird-ass conversion of quadratic formula to do this, where the coefficient would be y. Screw that. We're just going to solve this for y, subtract the x squared, divide by x, and then slam that bad boy in there. So that's part A. How do you guys feel about that? I mean, it's one thing, like you said. It's one thing to sit there and watch me and say, okay, that makes sense. It's an entirely different thing to be able to do it by yourself. So what's more important for this kind of problem than the specifics of this problem is how do what I just did apply to other problems? Find what they tell me, write an expression for it. Write an expression for what they asked me and see how they connect. Bam. There's a process. There's an avenue of attack for this kind of problem.
They just don't.
It's the overly dramatic door. Yeah.
Again, forget what they gave you, I still got how you made it.
So you're cool with this? Or no?
No, I'm cool with the picture, I'm not cool how you made the picture.
Gotcha.
X squared.
So the total area
X squared y.
would be the areas of all the sides added up. So I've got one side here in the back panel. The second one here is the top one. The third and fourth one are the sides. So I got 4 sides. 2 of them are squares. So there's my 2x squared. And 2 of them are rectangles, x by y. So there's my 2xy's. So my total area of this thing is going to be that expression. And they told me it equals 1200. Cool. If they didn't tell me that, I couldn't do shit with this. Yeah.
And that's surface area?
Yes, surface area. It's got to be. No other type of area I can involve.
Right.
Yeah.
Base times
Oh, there was 2 more rectangles.
so your volume.
No, they tell you the bottom and the side are open. So then you can slide your plants or put it on top of your plants.
How do you get the second equation? The second one.
Then they ask you to write an expression for volume. Now from the picture they gave us, I know the volume. It's length times width times height. I just pointed to the wrong things, but you're with me.
They asked for the volume.
Length times width times height. So x times y. There's no question about that. The minute they gave me the picture, I could have written that volume equation down. The thing that I need is there's too many freaking variables in there. I need this other expression to rewrite one of the variables in terms of the other one. So I haven't finished this yet. Well, like I said, you got to slam this thing in there. Yeah, listen.
Where it says x squared plus x y equals 600, can you factor in x out or no?
You could, but it wouldn't really get you anywhere.
Would it be like y equals 600 over x minus x?
Certainly.
That would work.
I like it. So you could factor an x out and then divide it, and then, yeah, that's fine. Because that's equivalent. This is the same thing as 600 over x minus x squared over x, which is just x. Yeah, that's cool. All right. So I'll let you finish that up. Because that's not even part B yet. Part B,
Let's graph it.
draw a graph, and they got a little calculator sitting next to it. Some of you guys got a little too calculator happy in the last couple sections in 3. If they don't have the little picture of the calculator, you probably need to show me some work as to where the graph came from. And then part C says, what dimensions will maximize the volume of the shelter? Well, once you graph this thing, you might see something like, okay, there. Find the highest point, right? Is that cool? The types of things we can do by hand in this class are quadratic. They have to be in the form ax squared plus bx plus c, and then we can do negative b over 2a. Remember all that stuff? To find the max or the min, if it opens down or up. I just did that backwards. Down or up. This kind of expression is not going to be something we can handle in this class by hand. That's why we have to use a graphing calculator to find it. I don't think. Or actually, yes, it will be. If I put this in here, one of the x's cancels. So then you just put 600x minus x squared. Yeah, that's a parabola. I could find that. I don't know why they made it
So close.
graphing calculator problem. It's an easy problem.
Well, because they wanted us to
Negative b over 2a. What's b? 600. I like it. It's not the number that shows up second. It's the coefficient of the x term, right? A is negative 1. So it'll be negative 600 over twice negative 1, and so forth. You can do it by hand, no problem. Okay, cool. Yes, sir?
Did you do 50 from 3.3?
Do you have to keep your coefficients? Or I mean your units, like your inches squared?
Yeah, at the end you better throw inches on there and inches square, yeah.
So
At the end you're going to get dimensions. You're going to get like 7 by 12, so you better
So
say
your
7
volume
inches.
down there will be 600 inches squared.
Here?
Is
it Yeah.
cubed or
Yes.
Everywhere. But when I've got an equation, I'm not going to throw units on top of that.
Okay.
I'll just bring the units back in at the end.
Okay. Is it x cubed or x squared?
Squared, because one of the x's would... Is it squared or cubed? Maybe it is cubed. That's why it's...
It's not working out as a problem.
Okay, that's a cube.
Okay.
I did that a little too quickly.
Okay.
Thank you.
Yeah.
So that is something you need to do in your graphic calculator. Now it makes more sense. Yeah. Okay. Let me do this a little more meticulously.
Okay.
So far we got the volume is x squared y. When we throw in there this y expression,
X minus x cubed.
1x cancels, so you do get 600x minus x cubed. Just my fault. It does come out to be a non-quadratic. It's a cubic. So then I do need the calculator's help to find this out. So when you graph this, it shouldn't have the basic shape. In fact, what's the end behavior of this? Yeah, it's going to be up here and down there, right? So it's going to do something like that. So you're going to have a maximum there. So you can use the calculator to find that maximum. Is that cool? In calculus, if anybody taking calculus, this kind of problem would be very simple. A couple steps after this, we can do that by hand. Once you have all the calculus at your fingertips. Right? So right now, we just use the graphic calculator to help us out.
Huh?
It's just small.
Oh,
Yeah, it's just not working out for me.
do your Y really big and your X regular. Fix me that.
Yes, it does. I think it was trying to just go down about this.
Ah.
The Y even bigger.
Yeah, that's right.
It's gotta be like this.
Oh, you want your Y bigger?
100, 6,000.
All right, so let's take a look at this thing.
100, 6,000 quarters. I
Wow,
can hear.
that's insane.
Turn
I
it
never
off.
realized. He's not even here today.
White noise. What do you have
This
in
is
that?
what I was going to do. I said, oh, this is very useful. I'm low on water. Oh. Oh. It's like having a backup battery. I have to do that again for him when he's back. All right.
So we can't use this negatively over 2. That's not going to work out.
Yeah, fine.
Okay, so now that we know this, we can figure out the max, right? This is your kind of coffee too.
So has anybody seen that comet yet? There's the lesser of the two comets. There's going to be two comets.
Yeah. I like the
This one, if you go out and wait about half an hour after the sun sets,
Tonight?
you look a little bit above
Right
the
now,
sunset, you find the moon, and you look a little bit above that, and you can see it should be as bright as a star. At the end of this year, we're going to have the other comet. I always forget the name.
Jesus.
There's a difference. So the one today is the one out there right now is Comet Pan-STARRS, and the one coming is Comet ISO or something like that.
Do you have to be at the beach? Do you have to be at the beach?
You have to probably be away from
You have to be at
bright
the...
lights.
We live super far.
Well, you can't see it unless you can see the coast, because it's that way.
Exactly. You got to be away. You got to be able to see
Or
because it is
that
pretty
way.
low, and then it
Oh,
sets,
yeah, 'cause the
and then
moon
you're
is-
screwed. You have to catch it pretty quickly after half an hour after the sun sets. You don't want to go through all that trouble.
You have to be near the woods.
Just Google it, and you'll see pictures.
Yeah.
Just
The
like
news
I'm
will have
looking
it on
at.
it.
So is this the max dimension?
Maximum, yes. Looks like a killer.
So is it...
Have you guys ever seen a comet before?
A
There were a
shooting
few
star.
comets a while back. One of my favorite was Comet Hyakutake,
Because of the name?
which if you look at it right now, it looks like it's saying Hiya Cutie. Comet Hiya
But how
Cutie.
is that
Easier to say
possible?
than All right, let's see now. The,
How is that possible?
I just throwing out random things. What? Let's get back to pre-cal. What?
What dimensions will maximize
Was
the
it
volume
600
of
x
the
minus x
sensor?
cubed?
He's giving us a solution.
Now, if you try to graph this thing, of course I can see because my window's all freaky. Try to graph this thing in a standard window, you're not going to see anything.
Nada.
No, nothing.
But then you start to analyze it just a little bit. I mean, 600x minus x cubed. You can take an x out. This should have a 0 at 0. This has a 0 at plus or minus square root of 600. And the square root of 600 is in between 20 and 30.
That's big.
So you have to be able to see up and down to 20 and, let's make it 30. You guys kind of see, or, you can see a lot of faces. Or you can look at the table. And, oh God, I'm way up there. Where the table's set. We haven't done too much with this table, but put it around 30. No, Jeff, you gotta look at the table.
There.
See how it's approaching 0? There you go. Now I can see right in between 24 and 25, it's got a 0. And it's really steep as hell. So just look at the table, I could tell I want my y's to be like
But you could also do
pretty
that.
crazy big. Let's make it
Right?
50,000.
Yeah.
Oh, Jeff, you probably want the other way around. Negative 50,000,
It goes back to 0 again.
50,000.
Look, so you're looking for your map.
And the x's, they definitely want to be, let's go negative 30 to 30.
Because that's the maximum point.
See what happens there.
Smaller numbers in there.
Kick ass. And I can adjust it a little bit. I went a little crazy on the y's, which is
So then
fine.
y would equal what?
40,000 is probably good there. Probably even less than that is good.
How do I find my y? I have to go like, plug it in?
All right, that's about the same there. Good job. But at least I can see now. I can see the
It
maximum.
was 0.
It's going to be in here.
There's no way.
You with me?
This is X.
So,
and there's no way this
Just
is
having a
zero.
graphing calculator does not take away all your graphing problems, because you still have to know how to interpret it, and where to look, where to change, how to change it. But that table really helps out. It's a quick place to go to get a feel for where your graph is. All right, and you remember how to find the max or the min. Here I want a maximum, right?
What the heck?
Something's wrong.
I love it. Oh, cool. I like it. So you just have a different scale than I do. It's fine.
Oh, because you changed the scale.
Yeah.
But it's
I'm a
still,
little OCD about it.
oh, it's just really huge. No, it was like 6,000. I put in 6,000.
So you have.
Oh, that's pretty. Let's
Here.
use that.
So you can find the max.
It's like. I just gave you the answer.
So you gotta go to the left of it,
That one's better. I like this better.
right of it. Oh, check. I give it a guess.
Yeah, that's really big.
12, 14, blah, blah, blah.
Oh, you just have the exact same thing.
Yeah.
Is that cool?
Yeah. 14.
All right.
5 million.
Yes, sir. Oh, yeah. Oh, no, you didn't see any of that, did you? Poor little dude. People watching the video are like, what just happened? Yeah, Mr. Wizard wins from.
So I would say
I'm almost stoked to hear that there was a
5, 6, 5,
Kramer
6.
penny pants reference that went down inside this class.
Oh, really?
Yeah, she
Or you
went
can
up
just
with
do
it.
it because
You go, look,
And then she too was a flutter about man hands.
14 times 14.
Man hands.
14
Take that lobster quarter.
200.
All right, so this is section 3.3, number 50. Right. The deceptively small problem here. This one here? Yep. This one says, use the remainder theorem. To find the value of 1/4. So don't just plug 1/4 in, but use the remainder theorem. And the remainder theorem is something I went over very quickly at the end of one of these classes. Basically, if I do this, right? If I do this, so here we go, 2, 2, 5, 5, 3. Can somebody help me put that back together? Where did that come from? What does it look like this came from, possibly?
2x squared, 3x minus 2.
2x squared plus 3x minus 2 is...
X minus 1. X squared.
2x squared.
Let me do it like this first.
Oh, okay, so
2x plus 5, remainder
it's 2x
3 over x minus 1.
plus
Yeah,
5
plus
remain
3
plus
over
3 over x minus 1.
x minus 1. Is that cool?
Yeah.
So that's what that says. So then what does that really mean? That means that 2x squared plus 3x minus 2 is x minus 1 times 2x plus 5. All I did there was multiply that up. Now if I multiply that up and I apply it to this, what's going to happen? Yeah, so you just get that plus 3. Now it's much more apparently a remainder. It would go in evenly if it wasn't for those extra 3. So when I plug a 1 into this, it's the same as plugging a 1 into this. course, right? Because that is that. But when I plug a 1 into this, what happens to this piece? Goes to 0, so you're left with 3. So then the shortcut then says when you synthetically divide by something, the remainder is what you would get if you plug that into the function itself, and that's y. So how do I figure out what I would get to plug a 1/4 into this function without actually plugging it in? I set this up and then I look at the remainder. How would I set this up?
1 minus 1.
0, good.
Minus 1. You need to fix
It's
that.
like a horror movie that you're like, oh wait, okay, this is silly. This is scary. This is so now you just attack this 1/4. I mean, now it's just dealing with the fractions you're getting. Let's see if I can deal with this.
Oh my God.
Because to tell you honestly, I could put a bonus question in there that involves synthetic division with complex numbers. It's nowhere near as ugly or hard as it sounds. Don't know if anybody believes me. Huh? Why not? So what would P of 1/4 be? Negative 49 over 64. Yeah, cool. So even though that was ugly, it was actually it was easier than, maybe it was easier than doing 1/4 cube. Especially if this is a long problem. The more stuff you add here, this procedure isn't really that much harder, truly. So, I mean, you don't see this a lot, but a few people like to do synthetic division to calculate plugging stuff in instead of actually just plugging it in. Right? It's a quick way to do it by hand. Okay. If I had a problem like this, technically, by the book, could I do synthetic division? No.
No.
Right? But I can. Because I can just divide by, how does this bottom factor?
Plus or minus.
Yeah, I, good.
Square root.
So I can divide this by I and then divide what's left by negative I. And that's the same thing as dividing by x squared plus 1.
Yeah.
Would you want to do that? Maybe not. Yes, sir.
Wouldn't it be positive 49 over 64?
Yes, it would be. Yeah, good. Thank you. Okay. Oh. Thank you. And just to kind of go through this a little bit. Now this particular one is probably kind of ugly, but so you just attack it like normal. The 1 comes down, you multiply, you add, you multiply. So now I get negative 4i minus 1. Because I times I is negative 1. You add, you multiply. Now I'm going to get positive 4 plus I. So then I end up with 3 plus I. And then you can synthetically divide with negative I. How often do we do that kind of thing? Hell no. So now you see why I'd actually much rather do the long division here. Right? Now if it was x squared minus 1, we could divide by 1 and then divide by negative 1, and that seems reasonable.
Yes.
Right? So as long as I can break the bottom down into linear factors, then I can actually apply synthetic division. I can always break things down into linear factors. It's just that the zeros I get from them might not be things I want to use.
So how would you write the answer for that?
Well, I'm not done. I'd have to do
Oh,
my
okay.
negative I. Keep going. Yeah.
Oh, because you know negative I is a factor
Minus
too.
2 plus negative 4.
Yeah. Negative 4i's got no like terms. 2 plus negative 1 is plus 1. Cool. Yes, ma'am.
On the practice test,
Yeah.
like number 2.
Oh. That one's deceptively, the one about the inverse?
Just negative 3.
Yep. So it's the same thing as me asking, what's the cube root of w cubed? W, because you do that, right? So what's f of f inverse of whatever? It's whatever. Yeah. But just to make the point, I mean, this is much more general than this. This is a specific instance of a function and its inverse. This is any function and its inverse. Bam.
Yeah, we knew that.
And that's just an illustration of if I know something's inverse, I can solve equations with it in it, because I can undo it then and dig the x out. That's what solving an equation is all about, is digging the x out from underneath all the crap.
The answer would be x equals 3.
X minus 3.
Or
Oh, and that one it's
for this
W.
one, it's f of negative 1 of f of x minus 3.
It would be x minus 3. Yeah. Because the f inverse and the f just cancel. You're left with that whatever's on the inside. Whatever f does to x minus 3, f inverse undoes it. So you're left with x minus 3. Okay?
Okay.
Let me go ahead and give you guys the answer key. Might as well.
Okay.
Sounds like at least a few of you guys have had time to do some of these.
Oh, boy. Can you explain this one to me?
Explain it.
Okay. Yeah. Right. Okay. Answer x bar. So that's your base. So 3 and y.
Oh wait, no. Please answer equals f.
Oh. So it's 10 equals 3, 7,
Yeah, but he didn't say that. He didn't say that value was explicit.
So this is b to the a equals e. So this is b to the a equals e.
Just make sure everybody's on the same page. Homework through section 4.4 is due by Monday, and test and quiz corrections are due by Monday. What?
Are you numbered?
Oh, he's showing
All right, so I got a question from 3.7, number 90. Ooh, I like it.
This is log e 5.6 equals w. I usually am too. What?
Schwaller.
Yep.
On questions, like on number 2 you asked,
What? Number 2.
what did you ask? Determine and behavior roots. If you just draw on here you put through touch. If we draw that little, the number line and we do, plus through here, minus through here, is that the same? You want us to write out through touch?
I just think they're misnumbered. That's
Once you do that little thing, you should follow it up real quick with through touch or whatever. Yeah.
yeah, it is.
Just make sure that I know that you know what you just drew and what it means as far as the question.
Right.
Does it go through or touch it?
Like the number line you
So
did.
that would be the work part, and then
I need to write through.
real quick, I can't remember what I did in the last quiz. Somebody did that on the last quiz. I can't remember if I only took off a few points or not.
To avoid
I
that.
think I circled through or touch, and then I took off a couple points.
Oh,
Yeah.
okay.
That's you. There you
The
go. Test
numbers
case.
are off a little bit.
Wait, I've got a question on the.
You
Who asked it?
You added
Use. Oh yeah, I couldn't remember if I.
number 9. You added, so it's just like number 10 is number 9, 11 is 10, 12 is.
We'll just fix it on that.
Oh yeah. All right.
So number 11 is number 10.
Yeah, I could remember. This is from last semester, so I know I did a little bit of changing, but be careful when you get to number 9. It does not exist. Number 10 then on the answer key is number 9 from your test. I have faith in your ability to tease that out.
So 9 does not exist.
Number 11 is number 10. Number 12 is number 11. Cool.
Okay.
Cool. Don't say it says find the vertex, and he said natural log of 5 points. What the hell? So make sure it goes together. So guys, this one says this is number 90 in section 3.7.
3 of 3. I was right. This one. You're dividing.
This one says, how can you tell without graphing it that this function has no x-intercept
Oh, it's log 3 of 2. I was wrong.
and no horizontal,
3.7.
vertical, or slant asymptotes?
Huh? 3.7? What? What are you talking about? 3.7.
Freaky.
Where are we? What are we going
I
on?
have to learn all this.
I can remember this.
This was from a
What the heck?
question from homework.
Who knows what it is? Where is it? 3.7. 90.
So the thing with slant asymptotes, they are defined to be straight lines. Can you see, just by observation, what would you get if you did divide these? X squared. That's parabolic. That's not a slant asymptote. Then that's a parabolic asymptote. That's freaky as hell. Right? It would just mean that it could do, it would be something sort of like this. So it has to approach it. It can do whatever it wants to in the middle, but it has to approach that at the ends. Same idea as any kind of asymptote. So you can have all kinds of shapes of asymptotes. How did I know that it was going to have possibly a slant asymptote? What situation am I in?
Bigger
Top
than-
is bigger than the bottom degree, right? So that explains that. It doesn't have a slant asymptote because the difference there is 2. It's not going to be linear, so it's not really a slant asymptote. That's a truly diagonal asymptote, right? Which means a straight line. So it doesn't have that, so check. Why do I know it has no x-intercepts? Where did x-intercepts come from? Top? And can the top be 0? No, it can't be. It's a parabola that starts at 10 and points up, right? You can't set that equal to 0 and get a real answer. You get a bunch of complex answers, but no real ones. Check. No x-intercept because you can't make the top equal 0. Yeah. X-intercepts for rational expressions always come from the top because the only way to make a rational expression equal to 0 is if the top is 0. The only thing I could put in here to make it 0 is a 0 there. I could put the biggest number I can imagine down there. It's not going to be quite infinity, but the biggest number you can imagine down there.
Infinity minus 1.
I like it. And then raise that to the infinity power, and then raise that to the infinity power, and then raise that to infinity. It's still not going to be 0. The only way I can make a rational expression 0 is if the top is 0. So when I say find the x-intercept for a rational expression, you just care about the top. Cool. And that top can't be 0, no x-intercepts. It's obviously got no horizontal asymptotes because we thought it maybe had a slant asymptote. It doesn't even have that. Why does it have no vertical asymptotes? Probably for a very similar reason about the x-intercepts. Vertical asymptotes come from where? The bottom, the only thing we got left, right? And that's because the bottom tells me what's allowed for x and what isn't. So if you try to set this equal to 0, see what problem you run into. In fact, how the hell do I even do that? The nice thing with this one is factors.
7 goes to
X squared and x squared.
3 and
And
5.
of course, each of these, do they have real zeros? Either of those? No.
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 So it's got no x-intercepts, no horizontal, no vertical, and no slant. Freaky ass.
Oh,
Actually,
because
it could be
there's
like that.
no real answer.
It might be like
rational answer.
Because they're like eyes.
It's a lot of
It does.
Freaky.
Freaky people.
Well, no, underneath,
So if I were you, I would probably be graphing this thing right now. I would not be able to rest until I saw what this thing looks like. And that's actually
But it's not real, man.
what I'm feeling right now.
It's just irrational.
It's just like tiny little. It's like.
I'm happy with my 78.
Look at it, guys.
What's that?
Yay!
Never been so happy with a B.
Right?
Minus C plus. C plus. C plus.
I'd be happy if I got a spelling contest.
but he was, I could see.
I totally have like a B minus, like B minus science in this class right now, and I'm so happy with that.
Oh, I see it.
So technically our homework's not due until Monday, right?
Do it again.
Our homework is technically not due till Monday, correct?
Technically.
Yeah, your homework is always due the day of the next test. I killed it. Calculator. Oh, there it is.
Hello.
Okay, so.
Shut the door.
Oh, cool. That's close. It looks a lot like that.
It does look like that. It's like,
It's got not much space in here.
no.
I did both since I saw that one
Uh-huh.
has like I showed up on top of my side. So I could pull it out for
You wrote the eye on it.
Look at that.
See that? Look, look. If I was, I know I should have done it. Well, you better.
Yes.
Very fast. 77.
There was two ions like in my chart.
Yeah, plenty of.
That was like a negative
Should be easy because there's only like 4 choices.
I know in class, she was like, I asked her one of the things that she's teaching me. So they call that like
It looks like
Yes.
it's like spirograph.
You don't have to use any of the actual possible roots. You can use any number you want. Yeah.
This is my favorite.
The roots themselves might actually not come out to it. One of the answers could be one of the bigger roots, or the answer could actually be an irrational number that is right above the biggest root. So it couldn't be an upper bound. Does that make sense? Okay, shit. So one root could be, so the biggest possible root is 2. The biggest possible rational root, which could have like 2 plus root 3. Could actually be a real 0. So this would not be an upper bound then.
There is no.
So to show it's a bound, it doesn't have to be a possible 0. A bound could be any number. It just says you can't be above this. That's all it says. Yeah. So you use 100 just to be safe, right? Yes. Oh. Oh yeah. Sure.
It's because it's hard. I would lock the door so it cannot leak.
I know. I keep forgetting to bring my WD-40 if that would even help.
Yeah, it's just got to speed up. Page number.
Hey guys,
It's just haunted.
Huh?
Oh yeah, that one.
what's that?
Oh, that is 3.
Oh, that's
Divided by 4. Because the pattern is based on 4, right? You do it, Jeff.
that's negative I.
So at 4, it starts over again. I5 would be 1, blah, 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 with the
It's
I.
negative I because it's a prime number, right?
So all I got to do is see how many times 4. If 4 goes in evenly, it's here.
Negative I.
And if not, the remainder tells you where else you are. There's remainder 1, remainder 2, remainder 3. It's a very simple example of a cyclic, periodic or cyclic procedures.
Oh, yeah.
You see that a lot in mathematics. You see that in like the last digit of powers of 3 or 4 or 5 or something.
4.25.
Calculator will tell you.
So if you divide that by 4,
1268.25.
1268 and a quarter, so the remainder 1. So it'd be I.
Oh, it's divisible.
So remainder 1, so you know you're in the first step of the cycle, so the answer must be I.
Is that because
So you just.
573 divided by 4.
Like it says 0.25, that'd be 1/4.
Oh, you have to divide by 2.
Yeah, that's perfect. The awesome thing is it's based on 4, so if it's 0.25, you're the first one, 0.5, 0.75 goes in even.
0.25, so there's 1 left over.
Cool.
Jeez.
there's 1/4?
Uh-huh.
I like it.
What couldn't you just go?
Your
Second
upper and lower bounds question,
to
your,
the...
it was my lower bound in place of -4, yours you put -3.
Because then it
They're
gives
both
you a whack
lower
out.
bounds. I'm not gonna get.
No.
Okay.
In fact, I mean, if it was me in this class, I would use negative 1,000 just to be.
Yeah, I just did basically like -4 and 4, the biggest and smallest. Well, those are probably up.
I like it.
Oh, yeah, math and then fraction. Rad. It's so cool. I love that.
Wait, so like, that's not a fraction? It's still a decimal.
Okay, so do math. Okay.
Here's how you do it, guys.
Okay.
You got it?
No, it hates me.
So now here's what you do. Whenever you do this kind of thing, you subtract the whole part,
Okay.
and then you can change it to a fraction. Because that's all I care about is that
Okay.
piece of it.
Look how neat that looks.
Wait, what was I doing right now?
She's
Thank
like, can I do that again?
I know. I'm gonna.
Divided by 4.
Oh, cool. So number 70 on 3-3. I assigned this problem, but I want to be real careful because sometimes I'll ask people to factor something, and you know if I have and I say factor this, and then I get somebody telling me the answer is this. Why is that wrong?
Because you left the 3 out.
Because it's not factored unless the operations are only multiplication. This is subtraction still. That's not factored. Can't be factored, right? I know x is a factor of the first 3, but you got to find a factor of the whole number. Now, this problem is not asking to factor it truly. This is asking to rewrite it in a different form. So it says you could take this expression.
It doesn't explain it.
Oh. This is number 70 on and it's 3-3. You can take that expression and write it as in this format.
Oh, it's hard for that.
Which does not look nice. But if you'll notice, this format is much easier for plugging things in because everywhere you got to look to plug an x in is a linear form instead of a to the 4th power. So if I had to put 5 in here, I have to get 5 to the 4th power and go from there. Whereas here it's just 3 times 5, 15 minus 5 is 10, times 5 is 50, plus 1 is 51, times, I mean that's actually a lot easier to do by hand.
Yeah.
How often do you see this format? Not very often. So obviously then the advantage you pick up is not enough, right? But this is something that's come out through math. And then you do actually use this kind of thing very often in computer programming to decrease the amount of time it takes for the computer to do the calculations required. You write it using nested form.
Yeah, it's true.
So I see a few of you guys shaking your heads. Yes, you understand what I'm talking about. So this one, it just says, try to write a different polynomial in that form, and then try to plug a value in. So if you could tease out how this was done. Well, do you notice there's 3, there's negative 5, there's 1, there's negative 3, there's 5. I mean, this one I really want to leave up to you because this is what math is all about, noticing patterns and then trying to repeat that process from the pattern you noticed. Yeah?
They want you to do this during your class.
I'm not really trying to divide by anything specific. I'm just trying to break up the problem in a different form. It's not really the same idea. Yeah?
How did you exactly break that into?
Well, think about it.
Well, the way I did it was to copy it out of the book. But, for this specific problem. But how do you really do this? You'll notice that this has got, like if you look at the first two, it's got an x cubed, right? So you notice how there's an x, and then there's your x to the fourth power, right? So if I gave you a different one, let me see. Okay. So you know you're going to have the -7 out there. And there's going to be an x sitting out here. Right? You almost want to work from the back. Then you can put, now you can praise, and that's how you kind of pluck it off if you start working from the back. So now you have a 5 plus, and notice how now you can pick another x out from in here. You got to be okay. Now how many x's have I taken out so far? 2. So now this is 2x first, and now it's just a -2.
Oh.
You guys follow?
X.
So if I write another x here, how many x's have I taken out total?
3.
So now this is just going to get +7 here. And then here you got your 6x. And now you got to make sure you get there, there, there. Whew.
So you set it up?
Oh, I see how you
Say
did
again?
that.
Y is going to be like 3 classes.
See how you did that there?
Why?
No.
So you need this one and this one to go together. You need this one and this one to go together. You need this one and this one.
That's the worst.
That's the most direct answer. Are you asking why it had to be 3 sets total? Because I had a 4th degree problem. So I had to take x out. How many times do I have to take x out? 1, 2, 3. And then the last x stays in. So every step you got is basically like a linear, in a way. When I start plugging a value in, I have nothing but linear things to really calculate here. I don't have to raise anything to a power. Okay.
Your battery's low.
Oh yeah. Oh, I always forget that I have a built-in battery. Thank you. That's gonna be a neat part of the video. All right. Is that cool? So now you should be able to do the one that they give you to do in that problem. That's kind of neat, though. I mean, there's a lot of stuff in mathematics you guys never get to see because it isn't like generally useful, but it is incredibly useful in very specific situations. Yeah. Number 15.
Apparently it's that easy. But I don't know how
Somebody remind me, what does this
I guess.
graph,
I didn't think it was that easy.
very rough sketch, what would it look like? I like it. Cool.
It looks like whoops.
So an exponential is like this, and a logarithm is just the inverse of that. So every logarithm is basically going to look like that before it's been shifted around. So what is the domain of this logarithm by itself? What's the domain of any non-shifted logarithm? What's the lowest x can be?
-3.
X. Careful now.
Oh,
0.
I can't even plug 0 in, can I?
Oh.
And why does it make sense? What would log of 0 have to be?
1, 10.
It'd have to be the power that I raise.
No.
All right, why am I this thing? It'd have to be the power I raise 10 to get 0. And can you raise 10 to any power and get 0? Hell no. I cannot raise 10 to a power and get 0. I can't. Huh? I like that. I always want somebody to go, you can.
Well, because then because 0, if you raise it to 0, it's 1.
Exactly. And if you raise it to a negative power, it's just a fraction with a 1 on top.
Really weird.
You can never make it 0 then. And we know that actually from the dotted line. That's actually the whole idea of this.
So it's
It never gets to 0.
It never gets to 0.
So the log of 0 is undefined. It's not a part of its domain.
So it's all round numbers greater than 1, right?
And another word,
Greater
that's
than
an
zero.
asterisk. So my domain starts right above 0
Okay.
and goes to
Infinity.
infinity. So that's still not answering the question. Where we had the question.
What chapter was
You do. The question is, what's the domain of this?
it?
I forgot what it was. Thank you. So real quick, remind me, how do you find the domain of that? What do you do to find the domain of that? I like it. You write in words what you would say. What would you say? What can't be true about, what has to be true about the inside of a radical, of an even radical? It's got to be at least 0. The inside must be greater than or equal to 0. And then you solve it. Now you do the same thing here. What's got to be true about the inside of a logarithm?
Greater than
Greater than 0. Right? So this would be 5 minus x greater than 0. So there are a lot of similarities between radicals and logarithms. That's almost the same. It's just that logs can't even handle 0. So you solve that, you get x has to be less than 5. Which makes sense. If x was bigger than 5, you get a negative number in there. It would freak out. Yes?
So it doesn't matter what base it is.
The base is kind of understood. The base has to be a number. It's a little weird because for us, the base is going to be a number above 1. In fact, for us, it's going to be a whole number above 1. But you can actually have a lot of different things as the base of a logarithm. But we're going to stick with that. Yeah.
If you had a negative base, could you have a negative number inside the parentheses?
We won't go there. I mean, if you have to really carry out the implications of having a negative base, and what would that mean?
Can I just make the number would be odd?
Because we have a negative base.
I mean, your power would be odd.
Right, so if I wanted to do this, I couldn't do it, could I? Because I have to cube it, but cubing it would have negative 8. So I could have that. So it leads to really a very strangely shaped function.
It's not just the same as saying longitude.
No way. No. Okay. Yes, sir.
If I were to write the log e of blah, 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 so number 11 is e to the power of w equals 5.6. I rewrote it as log base e of 5.6 equals w. You have it on here as a line. Should I just, is log base e, should it always be ln?
Yeah. In fact, what did I say about log base e? Right before I wrote it on the board? So that's the only time I'll ever write it. That's actually the only time I ever want to see it. Ever again.
Really?
Totally.
Okay.
Log base e does not exist as a symbol. ln means log base e. And I know that's kind of like, come on, dude, but, yeah.
So you might us wrong if we do log base.
Hell yeah.
Okay.
I think that's the takeaway from that.
That's so we can use another variable that uses e in a natural log, right? So we can use like
Oh yeah, you could have e in the log.
Alrighty then.
You could have like log.
It's like writing
L
10
and
logs.
Yeah, you have ln of e.
equals
So that's
W.
yeah,
Yeah.
log base e of
Right
e.
there. I heard you loud and clear.
It's the same thing as ln. No, I didn't. This is natural
7.
log of e.
Okay, okay. Just checking you out.
What would this be? I like it because these kill each other. ln is understood to be log base e. Log base something of that thing, those cancel. They're inverse functions of each other. Right. Maybe.